Okay, cool. So yeah, everyone should go to the course textbook and then go to like containerization and then pre-class to-dos, and then you can see how to install Docker on here, and it links all the installation packages you need and stuff. And make sure to also create an account on Dockerhub. So yeah, I'll just continue giving y'all some time to do that because I know it takes a while. And then once you have it installed, make sure you like open Docker, because this sort of runs, the Docker app kind of runs in the background of everything and like sort of does what it needs to do. And yeah, so make sure you have this open or else the process of Docker won't run. And yeah, if you have any questions, feel free to just raise your hand and someone will come help you. But can everyone like raise their hand when they're done, or give a thumbs up or something when they're done installing? Okay, so I see a few, but I don't see a lot. So I'll just give you all, I guess, 3 more minutes maybe. And then also if you have everything like installed already and like the Docker open, make sure to also open up the demo from last time. We're just going to be working on containerizing this app. And make sure you have your terminal open. Let me just make this bigger. Oh, you have a question?
So there's like a demo for starter code that's also linked in the installation page, but it only has the hello world endpoint. So if you did take, like copy down the demo from last time, you can use that. Otherwise, you're free to just containerize a bare-bone app that just returns hello world.
Yeah. So we're not actually going to be coding new routes today. We're just going to be working on actually creating the container. We're building an image and then creating a container off of that. So as long as you have sort of a working backend, that's all you really need. But we're just going to use demo 4 on this one. And can everyone like give another thumbs up if you have everything installed? Okay, I see more now, so I'm just going to continue. But yeah, if you have any issues or run into any issues, feel free to just raise your hand. But the first thing we're going to do is create, where we're just going to test our code to make sure everything works. So I'm going to activate my virtual environment and then just hit some endpoints. Oh, oops. Okay. So yeah, I'm in my virtual environment now. So I'm going to go to Postman and then I'll just get all tasks. Oh, I forgot to run the app. And yeah, I have get all tasks. I can. Oh, okay. Okay. And then I can create a task. I can get specific tasks. And yeah, all my endpoints need to be working fine. So I'm going to work on actually containerizing this right now. Let me make this larger too. Okay, cool. So the first thing we're going to do is create that Dockerfile, which basically tells the computer how we're going to run our server. So in our src folder, we're just going to create a new file called Dockerfile, and it's capital D, just Dockerfile, no like extensions. And you'll see this like whale pop up next to it, which is the Docker logo. And yeah, we're just going to create this. And then, so if you remember from PA1 or the demo one, to run your code, the first thing we need to do is actually install Python. And then we need to create sort of a working directory to put all our code in, and then yeah, copy all of it over. And then like run Python app.py. So we're in the Dockerfile, we're basically going to tell the computer to do the same thing. So the first thing we're going to do is sort of install Python in like this Docker file. So to do this, it's just going to be from Python 3.7. And this from indicates a base image. So this is the image we're building off of. So we're building off a Python image. And if you go to Google, you can actually search up Docker Python. And you can see that there's an official image for Python with different versions and everything. So this is the image that we're building off of, and we're creating a new image for our server from Python. So we're doing version 3.7, and then this sort of installs Python in the Docker container or Docker image. And then next, we're going to create a directory where all the code is. So we want to create a directory because we don't want all our like files just combined with all our system files. That just gets really messy. So in order to create a directory, we're going to use a command called run. And this basically just runs different commands. And the, I guess, command line command for creating a command, creating a directory is mkdir. And then we're just going to call it user app. And then next, we're going to set this as the working directory, which basically means that from here on out, everything we reference is going to be in respect to user app. So that's just WORKDIR, and then we're going to set it to user app. Yeah, so again, the from is basically sort of installing Python. And then this is creating a directory or folder to put like the app and db.py in. And this also just lets the computer know that we're going into this folder, and everything we do from here on out is going to be in sort of this folder. And then the next thing we want to do is take all the code in here and copy it over. So to do that, we're just going to do copy dot dot. And the dot, if you remember from the first, I think, demo, just means the current directory. So because the Dockerfile, I think, oh, it's not in here. So make sure to move your Dockerfile in the same sort of like folder as your app.py and db.py. And so the dot basically just copies everything in this directory in our src into this directory over here, user app. And then the next thing we're going to do is after we copy everything over, now we have a requirements.txt in this directory we just created. So we're going to run pip install requirements.txt like we always do when we have a virtual environment. So we're going to run another command, pip install our requirements.txt. And then the last command is a bit different. We're not going to use, oh, I'm going to make this bigger. Oh, is this a good size for everyone? Okay, cool. So the last command we're going to do in our Dockerfile is a bit different. Even though it's technically a command, we're not going to use run, we're going to use cmd. And this cmd, you should only have one in your Dockerfile, and I think you can only have one in your Dockerfile. But basically, it just tells the computer how you're going to run this app. So when you ran this, let me stop this real quick. We use Python, Python app.py. So the command to start the server is going to be Python app.py. So yeah, this is all we need in a Dockerfile. And usually we only have one of command and one base image and one working directory. And then, so if you ever in the future probably for Hack Challenge, you need to containerize your app. This is a very good sort of skeleton for how you're supposed to do it. Does anyone have any questions on how we created this and what everything means? Okay, cool. So now the computer knows sort of how to run our server in this container or image, which we use to build the container. So now we're going to actually build an image, which is the blueprint for which a container runs off of. So to do that, we're going to do just docker build and then dot, which basically means we're going to build the current directory. And it's really important that your like Docker commands all go in the same file as your same like level as your Docker file. So let's say we were in a parent folder for this, and then we ran like docker build, you would get an error because you can't find the Docker file. So make sure you're in the same level / folder as your Docker file. So I'm going to do docker build dot, and then you'll see all of this in your terminal, which basically means we're building the image. So it's running everything we sort of declared in our Docker file. It's first loading the base image, and then like running like the Mixdera user app / creating the directory, and then copying everything over, and then running the requirements, and then finally creating that image, which is again like the blueprint for which containers are built off of. Cool. So I'm going to make sure that all my images were built, where this image built correctly. So to do that, I can just do docker images, and it shows me all the images I've sort of created / built since I last pruned it, which means like sort of cleared the history of this. So this is sort of just like stuff I've done in the past, but you can see that the Docker image we just built 38 seconds ago is here, and it's successfully created, and it has a size and everything. But if you notice, it doesn't have a repository where it's tagged like the other images down here do. So how do we sort of give it a repository and tag? So we're going to sort of alter our docker build command a bit. We're going to do docker build -t, and then we're going to sort of define the repository name. So I'm going to do my Dockerhub username /demo5, and then
People are still, because everything's cached for you, everyone's still running there.
oh, okay. I was told to slow down, so I will give you all some time to let the build start. We're finished building.
So the reason why it might be taking y'all a pretty long time to build for the first time is because for Kate, she's already used Python 3.7 in a Dockerfile before. And so it's kind of stored in her local computer, and hence you could just build off of a saved version of Python. Whereas for a lot of you, probably you're just installing it for the first time, and it's probably taking a really long time to install. So you can see here for steps 2 and 3 says cached. This means that it's already been run before, and it's just kind of like using a cached version or like a saved version of that command.
Okay. So yeah, once your Docker image finishes building, can you just like raise your hand or give a thumbs up? Okay. Just wait a few more minutes. Oh yeah. Again, like Docker images, when you run Docker images, I think you should only have one unless you've used Docker in the past. But basically, it's all the images I've created. So you can just ignore the stuff after done. But as long as you run Docker images and you get something that looks like this, you should be fine. could everyone like give a thumbs up if their Docker thing finished, or not Docker thing, Docker image finished building? Okay. I can solve Doesn't ignore it. But I don't think like I ran it like beforehand and it didn't like give me an error. It's just like not technically correct. Yeah. Okay. Could you this time give a thumbs up if you're not finished? Okay, cool. Okay, we're just gonna move on then. So yeah, again, if you noticed when we ran Docker images, we don't have a repository or tag, which is not very good stylistically, because what if you had a bunch of images like this and you don't really know what this is for and you have no idea why you just have this image here. So we're going to rebuild this image and we're going to give it a name so that name and tag so that you have an idea of what this is doing. So to do that, we're going to do Docker build again, but this time we're going to do -t and give it a name. So this name is called like my Dockerhub username, which is KS Leong, and then the name I want to give this. So I'm just going to call this demo 5, but you should probably replace this with your own Dockerhub username. And we'll go into why this is important when we like push this to Dockerhub, like probably on Wednesday, but yeah, make sure you do that. And then finally, we're just going to do dot to represent we're building this current directory. So when I do that, hopefully this one's quicker because you built this image once already. But once I do Docker images again, you can see I have a repository, a tag, and yeah, this is a lot more clear. And I sort of know what's going on, what this repository is when it's been made. And yeah, so more on Docker image tags. So image tags usually represent the version of your Docker image. So default when you run like the -t and it gives the tag as latest, but that might not be clear. So if you go to like the Python one, you can see they have a bunch of different tags that sort of show like what each one does. So this might be better. So if I wanted to make this even more clear, I can give it a date and to define, oh, if this moves. Okay, so to define a tag, I basically, after my repository name, I put a colon. Okay, my computer is being slightly slow right now, but I can give it a tag name. So I'm just going to give today's date as one. And then everything builds. And when I run Docker images, you can see I have sort of a different tag, and this is a bit clearer. And yeah, so that's it for today's demo. Hopefully you're able to build a Docker image, give it a name, and next time we'll sort of go into running this image / building container off of it and pushing it to Dockerhub. Today, the first thing we're going to do is from this image, an image is like the blueprint for which your container is run, right? So we're going to actually run this image so that a container is built from it. So in order to run this image, all we have to do is just do docker run and then the image name. So it's ks/demo/5. And then you can see that when we do docker run the image name, like the code runs like you would do it in Python 3 app.py. So it works the same way. So we're going to confirm that this works in Postman too, and we can do everything we did when we didn't have Docker. So let's try to get all tasks. And somehow it says a connection's refused. And so even though this is running perfectly fine in our terminal, the reason this is not working in Postman is because we haven't exposed the port on a computer to the Docker container. So basically what this means is that the port, or the container sort of has a port 5000 by itself, and you need to sort of map the computer's port 5000, which is where sort of the stuff like our server is running, to the container's port 5000. So in order to do that, we need to sort of create a new where we need to run it in a different way. So to kill like this process is like running continuously. So you can't control C out of it like you would when you run the server using Python app.py. The only way you can kill it is by just deleting or closing the terminal tab. So you would just like trash it here and you can just add a new tab. And yeah, that's basically how you would end the process. So to map the ports from our computer to our container, you would do docker run, and then we would do -p, and then 5,000, and then /it, and then our image name again. So this -p basically does what I talked about before, where we map the computer's port 5000 to the container's port 5000. So now our computer's port is exposed, and the connection should be working. And so I can confirm this by just trying to get all tasks again, and our code is working as usual, and we can just like create a task. So I can do finish plan spring break, and yeah, we can create a new task, get a task, and everything works as it did before. So again, to fix like the problem where the connection was refused, we have to map the port from the container to our computer. And so that would be like 5,000 to 5,000 with the -p. And so yeah. And then the -it basically means interactive terminal. And this allows us to control C out of this process. So this allows us to not have to continue like deleting our terminal tab and then opening a new one. And this is because the Docker container sort of runs in it's called like a daemon process. And basically this just means it'll continue running even if we control C. And so by making it interactive, we're able to sort of interact with it, and you can control C and end the process. So that's basically what the -it means. Does that sort of make sense to everyone? Okay, cool. So now that we've successfully run our container, there's actually a better way for us to sort of build Docker images, and we don't have to do all these tags. And so in order to do this, we have to use something called docker-compose. And so to do docker-compose, we have to create a new file. And so in our src, we can just create a new file, and then we can name it docker-compose.yml. And so YAML is just another file formatting template, and it's kind of like JSON, but the format's not the same, but the idea of like the format is similar. And so Docker Compose, I think this was discussed in lecture, but it's basically a tool that will allow us to orchestrate multiple services. So even though in our demo / homeworks, we only have one service, if you have a larger backend service, let's say like Ithaca Transit, for example, we have multiple services running. We have one service that gets the inputs from the front end, another one that actually calculates the routes, and then another one that formats the like the routes that we get from someone in a proper format. So we have all these services, but in order to sort of orchestrate them together and manage them in a more centralized way, we can use Docker Compose. So yeah, that's basically the purpose of Docker Compose. And in our Docker Compose file, the first thing we want to do is to find a version of Docker Compose. So this is just going to be version :3. And then we have to name all the services in our sort of backend. And this one, we only have this demo. And within our demo, we have to define the image. So the image we made here was when we created this image, it was called /demo. And then next we have to map the ports. So we'll just do 5,000, 5,000. And so we're basically running this command in this Docker Compose file so that we don't have to continue making this like long command whenever we want to run the Docker container. And yeah, this is the image. And when you do the assignment, it's super important that you put your Docker username here, because basically in the assignment, we want you to push to Dockerhub. And if you don't do this, it'll try to search for like this image name demo from like the grader's local computer instead of pulling from Dockerhub. And so this username basically tells us where to pull it from on Dockerhub. So it's really important that you do this when you're doing the assignment. And yeah, that's basically all that's in your Docker Compose file. But if you had like multiple backends, you could, or not multiple backends, multiple services or multiple containers for your backend, you would just continue sort of adding this service to this under services. And you could sort of have different ports for each one and different images. So yeah, that's how the Docker Compose file works. And now we're going to just run the Docker Compose file. So I do Docker Compose, and then we could do up and then -d. Oops. So when you run Docker Compose, it's also really important that you're in the same directory as your Docker Compose file. So this is very similar to when you're running Docker builds. You have to be in the same directory as your Docker file. Similarly with Docker Compose, you have to be in the same directory as your Docker Compose file. So yeah, that was the error I was getting because I was not in the right directory. So let's do this again. Oh, I think it's called demo 5, not demo. So this command over here is just indicating that our container was successfully built from the Docker Compose file. So it's super short. You don't have this whole thing running. And the reason that is because this -d basically means detached, and we're basically running the container in the background, and there's no terminal sort of associated with it. So this means that we can't actually control C out of it like we did with the interactive terminal up here. But let's just test the ports to make sure it's still working with the Docker Compose. And we can see everything is still working as it was before. So yay. So So yeah, this is just another way for you to build images, but this is a lot easier and a lot more simpler. And to actually kill this container, we would do docker-compose and then but before we do that, I have to show you how to check which containers are running. So if we do docker ps, you can see I have multiple containers running. But ignore this one because this is when I was testing and I forgot to kill it. And this is the one we ran before with this one up here. So when you Control-C out of it, the container doesn't actually stop. You have to kill it by yourself, or the Docker sort of just naturally shuts it down. But this one that we just created is the one with the Docker compose. And this is the one we, again, created with Docker run. And this is just all the containers that are currently running. And so if I wanted to sort of take down this container, I would just do docker compose down. And so it stops the container. And I'll just wait for it to finish. And you can see it removes it. And so when I do docker ps again, I only have the one I created before and the one I was using to test for this demo. So you can also like delete a container by doing docker kill and then taking the container ID. And so once I do docker ps, you can see that the container up here is gone. But this is sort of like a less elegant way to remove the terminal because you're sort of manually forcing it to delete. And it's better to just let Docker stop the container by itself. But yeah, so with this image that we just created, or with this container that we ran up here, we're going to actually push this to Dockerhub, which is basically a place where you can, let me just sign in real quick. Oh, okay. So this is just a place you can see all your Docker images. Yeah, so I only have this one from, I don't know when I took this course. And but if you go to Dockerhub, you can see different images. So if you remember the Python image that we used as our base image here is on Dockerhub, and you can also just explore and see what else you can pull. And yeah, so to push to our Dockerhub, make sure you can make sure you first have an account. But once you have an account, make sure you log in. And mine is automatically like authenticated, but if yours isn't, make sure to type in your username and password. And once I'm logged in, I can just push the image by doing docker push and then the image name. And so you can see all of this. Can everyone, if you are not logged in, could you just, don't have an account, could you give me a thumbs up? Okay. I'll just, so this part is like pretty easy. So if you don't have Dockerhub set up, just make your account. But if you do, just go ahead and push your image by doing docker push and your image name. And then this process takes a while. So we can just wait for that to happen. But yeah, this process is very similar to like the Git and GitHub scheme. So, similarly to Git and GitHub, you can pull Docker images, push it, and when you commit it, it's sort of just like building it locally, but you need to actually push it to put it onto Dockerhub. Similarly to like GitHub, if you're here for the GitHub lecture or Git lectures, you have to commit it locally and then push it to GitHub for it to actually show. And this is taking a while, but we'll wait. And oh yeah, when you're pushing your image, again, it's really important that you have your Docker username before your sort of image name, like in this format, or else your image won't show in Dockerhub. Oh, so in your terminal, you can just do Docker login. And once you see a login succeeded, that should mean you're successfully authenticated. Sorry. If your laptop is like faster than mine and your image has successfully pushed, you should be able to. Oh my God, that was scary. I'm like scared to touch it. Okay. I'll just stay still. But yeah, if your Docker image was successfully pushed, you should be able to like refresh and see like a new thing pop up with the image name. But this is taking a while and I don't know why. Oh, yeah.
It's on the Chrome, yeah.
Okay. Since this is taking a really long time, I'll just show y'all how to pull the image. So, okay. I don't know how to prevent this from happening.
Yeah.
So I'm gonna open a new terminal. But if I wanted to pull an image, I could just go to Dockerhub and oh my God. I'll just pull this image, which is just like a very simple Docker thing that allows you to say hi with the Docker whale. And it just, it's like in the Docker tutorial for how you learn Docker. But if I wanted to pull this image, I would just do Docker pull. And then I would take the image name. So I Docker pull Docker/whale say. Oh, I did it in my demo for like sort of workspace. So okay, so now when I do Docker images, you can see I have this image I just pulled called Docker/whale say, and I can run it like I did with the one that we built. So Docker run Docker/whale say. Oh. So I have an M1, so I might have a special command. I think it's wait, give me a sec. So I guess this is one example of how you would use the image. And oh. Okay, yeah, this is just an example of how you can pull an image and run it. All the extra hassles in the middle was because I have an M1, so you have to like do this extra tag for your platform. But yeah, again, I just wanted to show you how to like pull images, which is just Docker pull and then the image name. And then everything else after that, just like running it, is very similar to what we did in demo. But yeah. Okay, this is being really slow. But does anyone have any questions about anything? Where does Docker sort of make sense to everyone and containerization? Okay, so we're sort of at the end of demo, but yeah, hopefully this finishes pushing. I don't know why it's taking so long. Usually it's faster. I guess in the audience, has anyone successfully pushed the image? Okay, so I'm getting a few nods that it was successfully pushed for some people. So yeah, remember when you're doing the assignment to basically follow the same schema, and it's really important that you name it in this format, and in your Docker Compose, it's also called the right name so that you do the assignment right. But yeah, that's basically all the commands you need.
Okay. So yeah, since that was a bit short this week, I wanted to quickly give, I guess, like a little explanation of what Docker is again, for those of you who maybe not were here on Monday, and also for those of you who might not have understood it, because this has historically been always the most annoying concept to teach and always the one that students struggle on because it's not directly code related. But it's very, very important that you know this for backend development. So let's just dumb it down a bit and explain what Docker is from kind of like a backed up standpoint. Again, an environment is the literal environment that your computer is running in. It has an operating system, right? Mac OS, Windows, whatever it is. It has your code, it has your dependencies, and it has environment variables. Environment variables, you can rewatch the lecture if you want to like catch up on what that meant, but it's not entirely too important for this week's lecture. Just know that you need an operating system, your code, and your libraries to run everything that you've been running in the course so far. Now, how do we run this on a remote server, right? How do we run this on other machines? We can containerize all our environment into what's called a Docker image. A Docker image is an instruction set on how to run your apps. So far, right, we've installed Python 3, we've pip installed our requirements, and then we've run app.py, right? That's the instruction set that we've manually told you to type into your computers. Now, we can make that computer readable by putting it in what's called a Dockerfile. We put the instructions to run on a Dockerfile so that subsequent users that may want to run our app don't need to, manually do everything by themselves. So we can just use Docker to run our apps. So the images, again, are the instruction set on how to run our apps, and our containers are the live instances of our apps. So yeah, and Docker Compose, the use of Docker Compose is to be able to define how to run our images or how to make them into containers without having to manually type out every command in the terminal. So you notice how Kate just now, right, did Docker run and then -p to map the ports and 5,000, blah, 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 blah. With a Docker compose file, so as such, we don't need to do all that. All we have to do is Docker compose up, and that's it. So that's what a Docker compose is. Docker images are the instruction set, Docker containers are the live instances of our app, and Docker compose basically tells the computer how to translate from image to container without us having to memorize it. Does that make sense? Okay. Please tell me, okay, please raise your hand if you don't understand, because this is very important to understand. Yeah, okay. So Docker compose, right? We have to build a container out of our Docker images. Our Docker images are the instruction set, and our Docker containers are the live running instances of our app. The Docker container tells the computer how to build a Docker container. The Docker compose tells the computer how to build a Docker container out of a Docker image. So Kate did Docker run -p 5,000 5,000 -it blah 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 blah. That we don't want to have to memorize and write out every single time we want to add run a Docker image. So the way we do it is just by defining how to run a Docker container in this Docker compose file and just running Docker compose up. Okay.
So what's the difference between the Docker file and the Docker compose files? Because it just seems like both has instructions that we put into the terminal.
Right. So the Docker file are the commands that we write on our terminal, right, to actually get started with running our app. The Docker compose file, on the other hand, is how to build a Docker container given a Docker image. So the Docker image is, again, the instruction set. Given this Docker file, how do you want me to actually like run it, right? Which port do you want me to run it in? Because that's not defined in the Docker file, right? These are everything you've written in the terminal. Docker compose tell us which port to run in, what image to run, all like a bunch of configuration stuff basically on how to run the Docker image. Anyone else? I think I saw another hand earlier. Okay. Does this all make sense now? Are we all good? All right, final call. Are we all good? Sure? Okay. Yeah, so like Kate showed in demo, when you Docker push to Dockerhub, oh yeah, Dockerhub. Dockerhub is the location on the internet where all our Docker images are pushed, our instruction sets, right? So that allows us for, if let's say Kate wants to run an app that I built and I pushed onto Dockerhub, she can just pull it and the mission, like her computer will understand the instruction set and will know how to run the app. So that's what Dockerhub is for. Okay. So hopefully that makes sense. Docker is pretty tough to understand and also pretty short because it's just like a bunch of commands you have to memorize, but hopefully conceptually that makes sense.
Everyone, I want to show y'all two more things I forgot to cover in demo yesterday. The first thing was I know where my computer took forever to push the image onto Dockerhub, but it did eventually successfully push by just doing that command. And the great thing about Dockerhub is, let's say I wanted to travel to California and I didn't bring my laptop with me, but I really wanted to show my friends this to-do list app I made. I can just go to my friend's computer, pull the image and run the image as a container and it'll work perfectly fine. And this is, again, really great because I don't have to go through all the different mechanisms that goes into like Git, for example, where I have to like clone the repository and then install the requirements and make a virtual environment and everything. So yeah, we love Docker. And another thing was I can actually go inside the container and see the files in it. So if I do docker ps, you'll see that I have all these different where I only have one container running, but I can go inside this container and see the different files in it. So if I do docker exec-it and I paste the container ID and say dash, you can see I'm sort of immersed, we're put into the directory of the container where I'm the root user or the admin user, which is basically what root means. And so if I do ls, you can see that all of the files in our VS Code workspace is in the container. So again, this is why we have this Dockerfile. It sort of just like creates the directory user app in this machine, which we are the root user of, and it basically runs the app as we do when we do Python.app or Python app.py. So yeah, that's something that's cool about Docker. And last thing was, if you noticed here, I accidentally built my Docker image with my virtual environment. And this is not ideal because virtual environments are meant to stay on your local desktop for it to manage requirements from like project to project. So to sort of prevent this from happening again, there's something called a dockerignore file. So this is very similar to gitignore, where Git sort of ignores different files that is defined in the gitignore file when you commit it or push it to GitHub. So if I create a new file and I call it .ignore, I can put in my virtual environment, and the next time I build this image, let's do build. Oh. Okay, so if I do Docker images, you can see I just built an image and I'm gonna run this image now, which I'll do Docker compose up. And I wanna run it in detached mode, so. Okay. So I do Docker PS and I take the most recent one. Oh. LS. You can see the virtual environment is ignored. So this is the best way for you to build a Docker image. And yeah, hopefully that helped. And yeah, good luck on the assignment.